Yeah, good morning, girls. Today we are going to discuss about linked list abstract data type and how to insert nodes into a linked list. I mean, there are different types of, different places where you can insert a node, like at the starting of a list, in the middle of the list, at the end of the list. So, how to insert it, these different places. Okay, so already we have discussed what is linked list. Linked list is a collection of um, nodes which can be stored in the which can be represented by queues or through dynamic memory allocation. So this is the abstract representation of linked list. So see here, this is first node which is pointing to the second node, and this is the third node, and finally the link field of the third node is null, which implies that this is the end of the list. Okay, so in C++, the entire linked list is seen as an object of class list. So list is a predefined class in C++ headers. So a namespace. Your linked list is treated as an object of that class, list class. So we have to define our own linked list class. See here. So each linked list has to have a special external link or pointer, say head. Why? Because we have to start, or we should know the starting of the linked list, from where uh, the other linked list has ended, or a new linked list is going to start. So it has to be pointed out by some node which is not part of a linked list. See, we call it an external link because it is not stored in the list. So our actual list is different. So this header's purpose is to only point to the starting node of the linked list. So this abstract data type is now a little bit modified. So with representation of the head. So this is also a node. Head is also a node, but it points out to the first node of our linked list, and this head is not a part of the linked list which we have, which we are going to define. See here. So this is how your class function looks like. So class list, and I am declaring this node as a pointer, this head as a pointer of data type node. Okay, and I'm declaring it as private. Why private? See, um, to stop the access of our list by unknown means, through unknown pointers, or someone who can modify or delete some important things, or just to avoid such kind of situations, we are hiding the starting point. So when you are unable to access the starting point itself, so you can't enter into the linked list. You can't access the actual members of the so-called linked list defined by us. So that is the reason we are defining the head node as private. So, and the other things are declared as public, because one node has to access the data and link of the other node. So if I declare private, every node as private, how come my node itself can't access the other nodes in my linked list only? So that is the reason we are keeping the nodes of our list as public. The member functions or data or links or whatever they are, we are keeping them as public, and the head node only as private, so that the starting of the list itself is used to hide the nodes. See here, the list now here, the list is having only one data head, one member, that is the head pointer, which points to the first node of the list. Where it points, what is the use of it? Which is used to access the list. So with the help of the head node only, you can access the first node of our list. See, the member functions including the constructor and destructor are used to process the list. So the member functions, whatever you define here, traversal or insertion or deletion, whatever. So these functions are used to process or perform some operations on the nodes of our list. So here the head is private and all other members are public. So all other members are public and head is private because see here, because particular nodes of the list are accessible to outside objects through pointers. So through pointers, we can try to access the objects of our list or the data in the nodes of our list. So to make that inaccessible, we are declaring head as private so that we can hide the information of the list which we are declaring. Okay, so this is all about your linked list actual definition. So now we will go on adding the methods into the list. So this is what your actual program looks like, but actually here we are not writing, we didn't write any code here, they are just empty methods. Here we are initiating head is equal to tail is equal to null. So this indicates your empty list. We have discussed in the previous class. So there is no node in the list at all. It is an empty list. So we are declaring two nodes here, head and tail, which start the sorry, which indicate the starting and the ending of the tail. And we also are trying to give the size of the list, specify the size of the list. But here we are taking size as 0. And so head and tail are initialized to null. So automatically this indicates your empty linked list. Okay, so these are the methods that you generally, or these are the operations that you generally perform on a linked list, that create, traverse, insert, append, delete, and reverse. Okay, so data structure of a node. So how the node actually looks like. So each node has data and link fields. So what each node has, already we have seen here. So each node has, this is the data and this is the link fields. So the data can be of single type or multiple types. The data field is not, or I am not specifying that it can hold only one particular data. It can be of different data types. I mean, two or more values can be stored in the data building. So here, each node has data and link fields. That is already on know that. The data field holds data elements and the link fields store the address of its successor and predecessor, if any. Why we are specifying predecessor? In case of a doubly linked list, you will be having predecessor also. Now we are discussing only general linked list. We are saying it as a successor. So what does the link store? It stores the address of its successor. So as the link field is a pointer to its successor, it should be a pointer variable which should hold the address of its successor. That is the reason we are declaring the link as a pointer variable. Okay, because it stores the address, and address is nothing but the pointer to that particular variable. Next, the successor node is of the same type as that of the node itself. Yes, each successor node is of the same type. How each node is, each node will have the same date, structure. Like data field and link field. So hence every node has one member which points to a node of the same type itself. So every node is having a member, that is link, which points to the node of the same type as itself. Okay, so that is the reason every node is a group of two or more data elements which are of different data types. See, every node will contain two elements. One is the actual data and the other one is link. So every node will have this data and link. What data, what type of data is stored is another issue. Every node will have this data part and the link part. So again and again we are having the same data type. So what we will do, we will group such data into a class. So that is the reason we are declaring the node as a class. Sorry guys. Node as a class which is having the data types as int. So this in this data type can be anything else. It will have two parts, data and link. Link is nothing but the pointer, and this link is nothing but again node which will point to the next node in our list. So it is a self-referential object. So the link field of a node is a pointer that references to the node of the same type as itself. So this link is pointing to a node which is of which type? Of node type. So that is the reason it is called as self, or we term it as self-referential object. So this is what about your uh, data structure of the node is. See here, node head, we are declaring it as private. So we have said in the previous part that always the head node is declared as private. So so as to avoid inappropriate access or to the nodes of our linked list. So So here the statement node link defines the link field of our node. So node is a data type of the pointer variable link. So what is this node? It defines the data type of this pointer variable link, because every link will point to a node which is again a combination of data and link. That is the reason we are calling it as self-referential object. See here, class node, you're seeing an example here, public int data node int data node link. So that link is pointing to first. So what is that first variable containing this first pointer? So what is there in the first? It is the address of A. So what if you want to access the data, you will write it as A dot data, which will give you the data. And if you are trying to access the link which is in that variable, which is in that node A, then it is giving you it as null. That means it is the only node that exists in our linked list. So this is how your access of the um, links in the node will be. Next, so this is your program where we are defining the method recursive traverse. Okay, so first we will see how to insert a node, insertion of a node. See, depending on the type of list or need of user, insertion can be made in three different places. First one is at the beginning, starting of the list, in the middle, somewhere in the middle of the list, and at the end, at the last position of the list. So if it is an ordered list, the insertion, we should also take care that in the insertion which we are going to perform should not affect the order. So this requires a lot of work. That means inserting data at proper locations has to be done so that the order is preserved. So you should not disturb the order of the whole list. So you should take extra care to preserve the order of the list. So to do such kind of insertion, first what we have to do is where the node is to be inserted, that has to be decided by searching through the list, obtaining the position, and then inserting the same. So first we have to find out where the position we have to insert, and first we have to search the whole list where our actual data fits in. You have to update the position, you have to change the links and insert a new node there. So we will see here how we are going to insert. So insertion of a node at a middle position. So first we are seeing how to insert a node in the middle of the list. So see the diagram here. This is a head node which is pointing to the first node. This is the first node, second node. This is a third node. Actually, without this insertion. Now, I am trying to insert this node in between these two nodes. So what happens? Actually, here this link field, what does it contain? It contains the pointer to this node. I mean, this contains the address of this node. Yes, but now this link has to be changed, or this address has to be changed to that of this node. So what I do, first I will create a node and I place this link field into this. So this is what I'm saying here. New node link. So this is new node. This is our new node. In this link, we are storing the previous link. Previous link in the sense this link. This link is getting stored in this node. Why? Because without emptying this link, you can't store the address of this node in this link. So first I'm shifting the link address of this node into this one, because this link is pointing to the address of this node. Yes. So see here, new node link is equal to previous link. Now at previous link. So this position is actually empty now. So what does it contain? It contains the link of this new. So you are doing two changes here. First one is taking the node. You are getting a new node, and in that link area, you are putting the previous link. I mean the link of the previous node into that, and you are in the next step. You are keeping the link of the new node into the previous node. See here how you will do the manipulation. New node is a node to be inserted after previous. So this node is to be inserted after this previous. The node that is a successor of previous will now become successor of new node. So the node that is a successor, I mean the node which comes after this node will now become the successor of this new node. Yes or no? Please see, this new node is coming in between. So now what will be if this comes in between? So to this node, what will be the successor? This will be the successor. Yes, that is what we are saying here. A node that is a successor of previous will now become the successor of new node. Okay, till now it was the successor of previous node, but now after insertion, this will become the successor of new node. So currently previous link holds the pointer to the successor of previous. So this link will contain what? Link to the this successor. So the link field of new node is set to previous successor node such that previous successor node becomes a successor of new node. So how we are setting the link? We are setting the link such that this new node, this successor will become the successor of the new node. It is no longer the successor of the previous node. So to do that, the new node link is, or shift the link of the previous node is shifted to the link of the into the link of the new node. So automatically this becomes the pointer to the successor. The new node becomes the predecessor of the node whose predecessor was previous, because new node is to be placed between previous and successors. So previous, the new node is coming between this predecessor and successor. So for this new node, this will be the predecessor, this will be the successor. So I'm taking out this link and putting it in this area. So for this, it will become the successor, and this address I'm putting it here, so it will become the predecessor of this new node. So here new node link is set as previous link, and that again previous link will contain the address of the new node. So these are the two main steps that you have to remember in the insertion of a node at the middle of a position. New node link is set to the previous link, and the previous link will contain the address of the new node. Next, insertion of a node at the first position. So how you are going to insert a node at the first position? So the head node, here the starting of the node is nothing but head node. So first you have to change the address in the head node such that it points out to the new node, and the address which is actually in the head node. I mean, the head node actually contains the address of this node, but you have to change it to the new node address, and in this, the field of this new node has to be set to head. So that is what we are doing here. So new node link is equal to head. So this the link part of this new node will contain the head, and what the head will contain, and now what this actual head will contain, because we have moved what the address is in the head to this link, new node link, because we are inserting first new node here. So what this head will contain, the address of this new node. So this is how the insertion is done at the first position. Say here new node. Till now the head is pointing to the first node. So now I'm changing. The new node link is pointing to the head. So this link, the head has to be moved to this link so that this becomes the first node. And now what does the head contain? The head contains the address of this new node, so that this will be the head or the starting of this point. So next, third one is insertion of a node at the end. So how we are going to insert the node at the end? So see here. So this in this pick or diagram, we are seeing three nodes. This is the previous node. Now you want to insert this last node here in the fourth position, so that it becomes the last node. So how the manipulations will be the same. New node link will have the previous link, as previous in the is the last node, previous link is null. So for this the previous link is null, so this new node link will have what, the address of this previous node, and this link will have, we will be set it to null. New node link will be null, because there is no link, there is no node after this particular node, so it is set to null. So new node link is equal to previous link, and previous link value is null, so new node link is null automatically. Next, previous link, for this, the previous link will be set to address of the new node. Okay, so this will make the new node the successor of the previous. So this link will contain the address of this new node, and this link will contain nothing that is null because it is the end of the node. So this is how you are going to insert a node at the last position. So this is about your insertions at various places. So this is your program how to insert um, your nodes at different positions. So here, see the position I at which the node is to be inserted is known. So at position, which position, we are assuming that we are inserting, we know the position where the I has to be inserted. And I already said there are situations where you have to search the list, and then you have to, if it's an order list, you have to search the list, then you have to find out the position and insert. So here we are assuming that we already know the position where we have to insert the node. Then we have to traverse till the I minus 1 position. See, for example, if you want to insert at position number 5, so you have to traverse till fourth position to insert a new node at the ith position. Okay, so I minus 1 node, so we will be changing the links. See here how we are changing. The previous node link will come into the new node, and the new node will link will go into the uh, previous node link's position. So this is how your program works. See, list insert at position. This is the method name. So new node, which is of which data type, no data type, and you should know the position. So it is in data type. So for taking temporarily initiating this temp variable temp to head, and count is equal to 1, flag is equal to 1. You're setting them like that. So if you are inserting at first position, the position is equal to 1. So this is what we will return. We have written new node link will be temporary. Temporary is nothing but your head. Yes, temp variable, what is it containing? The address of the head. What does the head contain now? Head will contain the new node. So this is the insertion at the first position. So we are updating head. Next, if it is not so, this is in the if block. Okay, if it is not in the first position that we want to insert, if we want to insert somewhere else in the middle, then so that will come to the else block. So first it will check the position. So we have seen for inserting in the ith position, we have to go to the I minus 1. So yes, so here position minus 1, it is not. Okay, so we will load the temporary variable with temporary link. If it is not null, only then we can go to the next, changing of the links. If it is null, then it is the end of the, what you say, list. So if it is the temporary variable is null, okay. See, if flag is equal to 1, then it is 0, then it is a null. So we have to break. If it is equal to 1, then you are shuffling the links. See, new node link is uh, will contain the temporary link. Temporary link means the address of the previous link, and the previous link place is occupied by the new node address. So this these statements are similar to these statements. Don't get confused. Here instead of previous link, we are saying it as temporary link. That's the only difference. So if you try understand this, you can easily understand this logic. So this is how you will insert a um, I mean nodes at different positions. Okay, so this is your main method. New node, new node. You are defining a pointer, new node at this of which is of node data type. You are also defining a list. You want to create and also display list. So now you want to enter a new node, insert a new node into that list. So first you have to enter the position. You are using the get node method to access the position of the previous node, and see here insert at position is the method, new node comma position, and finally you will display. So this, see, the code for this insert at position is written here. So once this method is called, it will take the new node address and the position, and it will check these for these conditions here in this if and else, and then it will try to put this node in that particular position. So linked list traversal. So how are you going through the linked list? I mean, what are the operations you can do by moving through the list? So linked list traversal is a basic operation where all the elements in the list are processed sequentially one by one. So you will be moving from one element to the other. You will be reading it, modifying it, or just printing it, whatever you want to do. You can do when you traverse through the list. So it is nothing but it is opening, or it is processing one by one node of the list. So what the processing involves, it could involve retrieving or only searching, sorting, computing the length of the list, and so on. So this is all we know. Again, see here. To start at the linked list, we need the head. So current is equal to head here. So if current is null, go to stop. Why go to stop? If it is the current position is null, what does it indicate? It is a null, empty list. So if it is not null, the data field of the current node is processed. Here the process may include printing data, updating, and so on, whatever operation you want to perform. Next you have to move on to the next node. So how we will move? This current is set to current link. So this current is pointing to the next node. The current will contain the address of the next field. Again, it will repeat if it is null, no. If it is not null, it will process whatever operation you want to perform. Again, it will check, it will change its value from the present address to the address next node's address. Okay, it will go to the next node. Again, it will check whether it is null and the address is null. No, if it is not null, the node exists, so it will do the operations and so on. So this is how you go on repeating the nodes till you reach till you need to reach the end of the list. So tomorrow this is all about your insertion and traversal of the list. So next tomorrow we will be discussing about deletion of the node. So if you have any doubts, ping me. Have a nice day.